So just a little introduction to piecewise functions. So how do we go about describing a function that represents more than one equation? That is what a piecewise function is, hence the name. So write in this blank, piecewise. So in order to write a function equation when you have multiple graphs going, you must divide the graph up into pieces that make it up, okay? We have our first example. We see that there's two pieces on this graph. Does everybody see that? Two different lines. Okay? So the first piece that we're going to look at is just on the left. Whenever we read these piecewise functions, start from the furthest left on your x-axis and then read it like a book, right? From left to right, okay? So the very first piece is this piece on the left. We can see that this piece is defined when x is less than or equal to 0. Does everybody see that? Okay, on my x-axis, I'm starting at 0 and going to the left. So less than or equal to 0. It is a closed dot, which makes sense because it's less than or equal to 0, right? Okay, so I'm going to erase that. What we're going to do is we need to find the equation of this line. So the first thing it asks me, what is the b value of that line? What is a b value? So in the equation y equals mx plus b, yep. So in y equals mx plus b, b is just our y-intercept, okay? So the b value here, and you might want to write that out to the side just so you have it. You know that that's a y-intercept. The b value here is what? 0. So I'm hitting the y-axis at 0 at this point right here. What about the slope of that line? So the slope of that line on the left. So slope is just rise over run, right? One over 1, but negative, right? So it's -1 is our slope. -1 over 1 is just -1. So what I need to do is just put that into my equation, y equals mx plus b. So it's going to be y equals -1x, or -x, plus 0. Do I need to write plus 0? No, I don't. So it's just y equals -x. Okay? And now we're going to look at that second piece. So that is this line right here that's starting with an open dot and going to the right horizontally. Do we see that? Okay, it makes sense that it's an open dot because it's x is greater than 0, right? On my x-axis, does everybody see how x is bigger than 0 for that piece? Okay. What's the b value on this one? 2. So it hits the y-axis at 2. What about the slope? 0. Good. Little flashback to pre-algebra. The acronym HOY, like the cookies, Chips Ahoy, that means horizontal, 0 slope, and then the y meant y equals. Okay, so anytime you have a y equals a number, it's going to be a horizontal line. Okay, so y equals 0x, I don't need to write 0x. Y equals 2. That is the equation for that second piece of that graph.
Wait, what is the y equal? And the different?
Just y equals a number, sorry. I know, I went off the edge. Here, let me move it over. Okay. Questions so far? All right, so our final answer on this one is going to look like this. Y equals, and then I'm going to draw this fancy little parenthesis here. Okay? Since I've already wrote y equals, I don't need to write it again for each of these equations. Yep, kind of like a backward 3. I'm not the best artist either. I could have made it a little neater, but it's okay. So for the first piece here, y equals negative x. I don't need to write the y equals again, but I just need to write the negative x. So y equals negative x if x is less than 0. Okay, and I got that just from what they told me right there. But I could also look at the line, or look at the graph and see that the line is only defined for x is less than or equal to 0. Okay? Then we have piece 2, y equals 2. So I don't need to write the y equals again, I just need to put the 2. If x is what? Greater than 0. Because again, I had that written down already. And that's it. That's my answer. That's how I write a piecewise function.
Do you need to do the close parenthesis thing?
Nope, you don't even have to put a closed parenthesis thing.
Can we?
Can you? I wouldn't. Okay. Moving right along here. So we're going to do another example. This one works very similar. However, it doesn't tell us where x is defined, so we've got to figure that out. Okay, so we'll start off with this first piece. Again, the piece on the left is the one I'm talking about. We'll start off by finding its equation first. So what's the b value of this line here on the left? Negative 1. What's the slope of that? Also negative 1, right? We can see it's going down 1 over 1. Negative 1 over 1. So the equation would be y equals negative x minus 1. Good. Okay. And now just looking at the domain of that piece. So what I mean by domain is just where it's at on the x-axis, where it's defined. What is my domain there? So this line's going to infinity, right? To the left. And then where's it ending? So on my x-axis. 0, okay? So x is less than 0, correct? Do we see that? How just the domain, it's less than 0. Is it equal to 0, or could it be? Yes, why?
Because it's close.
Yep, this is a closed circle, even though it's tiny. So I do need to have that equal sign. So less than or equal to sign instead of a less than sign. Okay. Now we're looking at that second piece. So start off, what's the b value? Yep, positive 2. That's where it hits my y-axis. Okay. And then what about the slope? 1. So the equation? Y equals x plus 2. Okay. And then where is x defined for this one? What was that? Greater than 0? Good. Again, don't get that confused with where it's at on the y-axis, just the x-axis. So x is greater, when x is greater than 0, we're talking about this line. Not greater than or equal to though, right? Because that is a open circle. Good. Okay, so my final answer, we're just going to put these two together. So it's going to be y equals our little piecewise parenthesis. What'd you say? Negative x minus 1. If
x is less than or equal to 0.
good. And then the second piece?
X plus 2 if x is greater than 0.
Perfect. Questions so far on that? Okay, so we're almost done, but we do have to add in the domain and range. Okay. Domain and range are a little bit different. Not different as far as finding them, but a little bit different than absolute value and quadratic. So absolute value and quadratic, my domain was always what? Negative infinity to infinity, okay? Sometimes, on these piecewise functions, that's also going to be my domain. Not always, but sometimes. And if we zoom in on this one, so my domain, again, is reading from left to right. So starting from the left, am I going to negative infinity? Yeah, okay. And then going to the right, are there any points on there where I'm not defined on my x-axis? I see some heads nodding and some heads shaking. So it should be no. Because even though there is an open dot right here on this axis, there's still a closed dot right below it on 0, right? So 0 is technically defined, okay, but only in one place. And then I'm going right to infinity, correct? Yeah, so the domain on this one is going to be negative infinity to infinity. So we'll go ahead and put that in here. Now we got to talk about range. So range works just like it did before, reading from the bottom to the top. So our negative values to our positive values. Where does this graph start? Negative 1. Good. It starts at negative 1 on my y-axis. Where does it end? Okay, I hear a lot of people saying 2. However, this line keeps going forever, right? So even though there's a gap right here at negative 2, or sorry, not at negative 2, at positive 2, isn't positive 2 still defined on this second, or on this left line? Yeah, because that's a solid line. So it's going to infinity. Yep. Good. Questions on that one? Okay. Example 2. Sometimes there's going to be more than 2 pieces. We know that. We've actually seen that on our very first homework quiz because a lot of us freaked out because we didn't do any in the notes that had 2. Do we remember? And we saw 3 pieces and we were like, oh my gosh. No one did that? Everyone's looking at me like they're confused. Okay. So we did have some that have more than 1 piece or more than 2 pieces. So this is one of them. This one's got how many? How many pieces? 3, right? Okay. So starting with just the left piece, what's the b value of this left piece? So this piece right here, be careful. Does that touch my y-axis? No, but if I had to extend it to figure out where it did touch the y-axis, where would it? Yep, negative 2. So you can extend a line to see where it hits that y-axis, but make sure you don't keep it extended because you might get confused. And then what about the slope on that one? Yep, negative 1. So the equation would be negative x minus 2. Okay? And just looking at the domain, so where it's defined for x, where is this defined? X is, am I putting a less than or a greater than sign? A less than sign. Is it going to be equal to? Yeah, because it's a closed dot, and where at? On the x-axis. Negative 2. Good. X is less than or equal to negative 2. Okay, second piece. So this second piece, what does that look like? A line segment, okay? When we have a line segment, it's not going to infinity in either direction, correct? It's starting at one place, or at one number, and it's ending at another. So when we write these, we're still going to have the equation of what the line would be, so we'll start with that. Where does this hit the y-axis? 2. What's its slope? 0. So what would the equation be? Y equals 2, okay? So that's my equation. Where is it defined for x? From where to where? Yeah, so from -2 to 1 right here. Do we see how it's defined? From that number to that number. So how we would write this would be x is between -2 and 1. So you'll use two less than symbols like that. X is between -2 and 1. Am I good to leave those as less than symbols, or should they be less than or equal to? Less than, right? Because they're open dots. Good. Okay. Piece 3. Go ahead and try that one. Okay, what do we think on this one? What would be the b value? -2. Good. That was one of the ones where we had to extend the line, right? Because we can't quite see where it's going. Ooh, I didn't get -2. Anybody get anything different? -3. That one was tricky. Okay. What about the slope of that one? It was 2, right? It's going up 2 over 1. So it would be a +2. Again, if you just draw a triangle from 2 points on the line, you see it rises 2, runs 1, so it'd be 2 over 1. That's a little way to find the slope if you struggle with that. Okay, so the equation for this one would be y equals 2x minus 3, and where's x defined? So I'm hearing 1, which is right. What sign between the x and the 1? When x is greater than or equal to 1. Because it's a closed dot, and we see it's going this way forever, right? Starting at 1. Questions on that? Okay, so to grand finale this, write it as one piece. The top part. -x minus 2. Perfect. Next part. Yep, just plain old 2. Yep, when x is between -2 and 1. And then the last part. 2x minus 3. If. Yep. Good. Domain on this one. So from left to right, where am I starting at? -infinity to infinity. Good. So on the y-axis, you said negative what? So that would be right here. -3. So it would be negative, where's the bottom? -1 to infinity. Does everybody see that? That's my lowest value. It's going up to infinity. Okay. Questions on that? Step functions. Okay. Given the following piecewise function, write the equation that would represent it, and then state the domain and the range. Okay, so this is what we call a step function. So if we look at it, it kind of looks like stairs, right? One function steps up to another, up to another, up to another. Are these all connected? Are they touching? No, they're not, okay? It's just a bunch of separate functions pieced together. So, if we look, if I had to write an equation for each of these lines, what kind of lines are they? they vertical? Are they horizontal? Yep, they're horizontal lines. So we are going to just go ahead and write this as a piecewise function. So the very first line, this one right here, what would be the equation of that? Y equals 2, right? Do we all see that? Y equals 2. So y equals 2 when x is between what two numbers? So just looking at my x-axis, if I drop down here, 0 and 2, right? So it starts on my x-axis. This is the point 0, 2, right? And it ends at 2, 2. So when x is between 0 and 2, my equation is y equals 2. Yep, good point. The first one needs to be a less than or greater than sign. What about the second one? No, because it's an open dot. Good. So now jumping up to my next step. What's this one going to be? 3 when x is between 2 and 4. Okay, go ahead and fill in the rest of this. All right, let's finish this one up. Next piece would be y equals 4 when x is between 4 and 6. Good. So that's this piece right here. I messed up. This should be just a less than sign. Okay. Next part. 5 when x is between 6 and 8. Then what? 6. We notice a pattern here, don't we? 8 to 10. And then 7 from, I didn't make this big enough, from 10 to 12. Questions on that? Okay. Domain and range of a step function. Are any of these lines going to infinity in either direction? No, they're not. Okay. So starting from left to right, where does this graph start on my x-axis? 0 on the x-axis, right? Because domain is all about x's, range is all about the y's. So write that down if you need to. Don't ever forget that. So domain, we said we're starting at 0. Is it equal to 0? Is it a closed dot? Yeah, so this should be a bracket. And then where am I going to? 12, right? Is it equal to 12? No. So I can just do a closed or an open parenthesis. Okay. Range. This one's a little bit tricky. So on my y-axis, where am I starting? 2. Aren't there a bunch of little gaps in between here, though, that aren't defined? Since this isn't connected, it's not a straight line. So how we would write this is just like this. 2, I'm also defined at 3, 4, 5, 6, and 7, right? So I'm just going to write those together, just like that. Questions on that? Step functions aren't too bad. Okay. Next up, we have graphing the piecewise functions, okay? So sometimes instead of giving us the graph and having us write the equation, they're going to give us the equation, and now we have to draw the graph. Okay, so it works the same way. The first thing I'm going to do is just divide this into the pieces, so work backwards here. Okay, so my first equation is y equals x plus 1. When x is less than or equal to 0. My second equation is y equals negative x when x is greater than 0. Okay? So on that first one, what's the b value? What's the b value? 1. And what's the slope? 1. Also 1. So I'm going to go ahead and just plot that whole line. So if I know that the b value is 1, I can put that on my y-axis. A slope of 1 means up 1 over 1. But I'm going to go ahead and save myself some time. It says x is less than or equal to 0. So when x is less than or equal to 0, am I going left or right? Left, right? So I'm going to continue to plot this line, but I'm only going to do it to the left, because I know that if I plot the whole thing, which I can totally do, I could plot this whole line, but I'm going to have to go back and erase because I only need the parts where x is less than or equal to 0. So the way I drew this, I started with a closed dot. Is that okay? Can I leave that? Yeah, because this is x is less than or equal to 0. I didn't mean to erase that. There we go. So this should be a closed dot. Okay, now I'm just going to go and draw the second piece. So same thing. What is my intercept on this one? 0, right? So I can go ahead and put a dot at 0. And my slope is -1 over 1. And this is defined for x is greater than 0. So this line needs to go left or right? Right, okay? So I'm going to go ahead and just draw this line with a -1 slope. I could have just plotted points down here. Down 1 over 1, down 1 over 1. But now I need to go back real quick. Am I okay to leave that as a closed dot? No, I'm not. I need to make that an open dot. So I'm going to do that. So that's it on graphing. So it's basically just working backwards from what we did with the writing the equations, okay? The domain on this, from left to right, what do we think? Good, -infinity to infinity. We do have a gap there when x equals 0, but I do know that it's defined because x equals 0 on this first piece. And then my range, so starting from the bottom to the top. -infinity to 1, so going to the top part. Good. Questions on that one? Okay. Number 2. Go ahead and try this one. So break it down into your 2 equations, graph them, and figure out where they're defined. Okay, let's go ahead and start on this one. So my first equation is what? Y equals x minus 2. What's the b value on that? And the slope, 1. Okay, so I can go ahead and start plotting this. Where is it defined? When x is less than 0, right? Okay, so I'm going to go ahead, plot my -2, use my slope, which is 1 over 1, when x is less than 0. So am I plotting left or right? To the left. You are correct. It should be an open circle. So I'm going to go back and change that. Okay. The next piece is the equation y equals 4x. What's the b value? 0. Slope, 4. And it's defined when x is greater than or equal to 0. So plot that b value on my y-axis. Use that slope to make more points on this line. Am I graphing left or right? I worked ahead of you. To the right, because it's greater than or equal to 0. Am I okay to leave that closed dot? Yep. Okay. So it should look like this. Domain on this one. So from left to right, reading my x values, am I defined for negative infinity to infinity? I think so. There's only one gap on the x-axis, and it's right here at 0, but I am also defined for 0, so I'm good there. And then the range, so reading from bottom to top. Close. So reading from bottom to top, do I have any gaps where I'm not defined at all on the y-axis?
Oh, yeah,
I do. I have one little gap right here. So technically that does disqualify that part from having a range, okay? So it's negative infinity to negative 2. Is it equal to negative 2 or not? What kind of dot is that? It's open, so I need to use a parenthesis like that. Okay.
If it's closed, is that when you use the bracket?
Yep.
Okay.
So then I'm going to put an or notation down. So my range is negative infinity to negative 2, or where does that next piece start? 0. Is it equal to 0? Yep, so I'm going to put a bracket on 0, and then where's that going? Infinity. Good. Yes. The U thing? So that's just showing, you can write or, but that's just the or notation. Okay, it's just saying that that's a union. Any other questions? That was a good question. Okay, let's keep going. Whoa, I don't know what just happened there. Oh. Weird. Okay, I guess I'm gonna erase all that. Okay. Example 3. So this is a 3-piece one. Okay. We'll go ahead and we'll start this one together. So my very first equation is y equals x squared. Ooh. Thinking back to parent functions that we had. Did we have a parent function that looked like this? Was it the absolute value parent function or the quadratic? Quadratic. What did a quadratic function look like? What shape? Was it a V? It was a U, right? Okay, so I know that when I graph this, it is going to be in a U shape. So it's not necessarily going to have a slope, right? Because it's not a straight line. It will have a b value though. So if it's the parent function, what was that starting point? Wasn't it just 0 because we didn't write it? Okay. And this is defined for x is less than or equal to 1, correct? I just got that from this. Okay. So I know that this starts at 0. But I only need this graph going to the left, right? So should I plot the whole thing or should I just plot points that I need? Just points that I need. So I'm going to make an XYT chart right here. And I know it's x is less than or equal to 1. So 1 is as big as I'm going to go. And then I'm just going to do a couple points that are less than 1. So I'll do 0 and negative 1. And I might just do those 3. I think that is good enough. So now all I've got to do is plug in those x values to that equation. So y equals x squared. So y equals, what's negative 1 squared? 1. What's 0 squared? What's 1 squared? 1. So now I've got 3 points that I can plot. So negative 1, 1, 0, 0, which I already got, and 1, 1. And we said it was x is less than or equal to 0, so we know we're plotting to the left. So I'm just going to go ahead and plot the left side of that u. I don't need to plot any further on the right. Am I okay to leave that closed dot on the 1, 1? Yeah, because it's less than or equal to. Okay. Our next piece of this is y equals 3 if x is between 1 and 2. So we can think back to what that's going to look like. It's going to look like a line what? Segment. Okay. We know that that means it's going to have a slope of 0 and a b value of, what is the number? 3. Okay. And just as she said, it's between 1 and 2. So I know I'm going to have a line segment between 1 and 2 at b equals 3. So it's kind of short there. I might need to zoom in a little bit. Okay, so between 1 and 2, and it's just going to look like a segment. Should I have open circles on both sides of that segment? No, which one should be closed? Yep, the one on the 2. I know, it is little. Okay, we'll zoom back out of there. And again, the 2 dot was closed just because this was a less than or equal to sign, right? The other one was not. It was just less than. Okay, and then the very last part. Y equals x. Okay, what's the slope on that? 1. The b value? 0. So starting at 0 with a slope of 1, but it's only for x is greater than 2. So what I'm going to do for this one, and you're free to do it however you can if you can visualize this, I'm going to go ahead and just graph this. I'm going to start with b equals 0, even though I know I can't leave that dot right there, okay? Because I just want to be able to visualize what this line looks like, and then I'll go back and erase the part I don't need, okay? So at b equals 0, I know I'm going through the origin, and I've got a slope of 1, which means I'm going to have these points right here. Okay, and I'm going to go ahead and just make that line. But now I know that it's only for x is greater than 2, so I'm just going to erase this part. Okay, you with me? So I just erased that part that was x is less than 2. Because I know I just need x is greater than 2. And then what kind of dot? Open. So I'm going to put an open circle right here. I can zoom in on that too. So it looks like this. Questions on that one? Are we good so far? Almost done. Okay, domain for this one. So from left to right, what do we got? Yep, this is an easy one. Negative infinity to infinity. It's defined everywhere. And then the range. 0 to infinity. Good, because this line doesn't break, right? So I'm covered for everything to infinity. All right. Real life application. Okay, so you rent a karaoke machine for 5 days. The rental company charges $50 for the first day and $25 for each additional day. Write and graph a step function that represents the relationship between the number of days, which is x, so we can go ahead and label that, number of days. I guess you could just put days, that'd be easier. So days, and then the total cost, which is our y. So So they start off by giving me when x is between 0 and 1 days, what would the cost be? So think about that. So make a graph on this one, fill in that table. You can work with people around you, and we'll go over that shortly. Okay. So let's go ahead and just make the graph. So it says that we rented it for 5 days, so we just need at least 5 days on the x-axis, right? So I'm just gonna go like this, 1, 2, 3, 4, 5. And since I know that it's just 5 days, I can go ahead and fill these in. So when x is between 1 and 2 days, 2 and 3 days, 3 and 4, and 4 and 5, right?
Would only one of them be like the greater than or equal to, or would they all have a line number?
We'll talk about that here in a second. Okay, so we'll put it into context here. So if I rented this machine for 0 to 1 day, okay, so it says it's equal to 0 and equal to 1. So between 0 to 1 days, what's it going to cost? $50. And I know that just because that was my initial fee for the first day. Technically, I don't know that this should have a line right here, but it's okay. And then it's $25 for each additional day, correct? So if I were to add another $25, what would the next one be? 75, then what? 100, then what? 125, and 150. And now we'll think about it in the context. So if I was equal to 1 day, what would the cost actually be? It would be 50. So I don't necessarily need that equal sign right there. But what if it was equal to 2 days? It would be the 75. So I do need a line right there. Again, I think this first one was a typo. Okay, so now I'm going to go back and fix my other ones, right? To follow suit. So if it's between 2 days, which means more than 2 days, but less than or equal to 3 days, it's going to cost 100. Same thing for this and this. So now I have a better idea of what this step function is going to look like. I need to go ahead and label my y-axis. So I need to go from at least 50 to 150, right? And it looks like we're going up by intervals of 25. So I'm just going to start with 25, 50. I'm going to erase that. It's in my way. 75, 100, 125 to 150. And again, that's costs. Okay, so now I can go ahead and draw this step function. So the first piece, when x is between 0 and 1, my y is 50. So from 0 to 1, and 1 should have a closed dot, 0 is a typo, but it should have an open dot. Because if we didn't rent a machine, we're not going to pay $50, are we? No. I would hope not. And then when x is between 1 and 2, so open dot on 1, closed dot on 2, we're at 75. When I'm at 100, I have an open dot on 2, right? Closed dot on 3. When I'm at 125, open dot where? 3, closed dot on 4. You with me? Open dot on 4 at 150, close dot on 5. Questions on that? What should I title the top part of the graph? Does it matter? What could we call this? Karaoke machine. I like it. And that is it on piecewise functions. Any questions on that problem? Or on any of the problems that we've done today? All right.